Good day, I'm Norman Wildberger, and welcome to Math Foundations, where we're currently putting set theory on trial. And to do that, we're going to go back in time to the origins of logic in ancient Greece. And the main aim that we're working towards here is this idea that logic actually historically belongs to philosophy, not mathematics. I want to make the case, and this is sort of the first foray into that. Okay, so I should qualify all of this by, of course, I'm not a philosopher, I'm a mathematician, so philosophy is a little bit alien to my way of thinking. And so when I present things, I'm going to try to be as impartial as I can and not be too judgmental, either for or against. And you should also perhaps take some of my pronouncements on philosophy with a grain of salt. But nevertheless, I think we can safely move towards understanding this very, very important point. And today we're going to talk about Aristotle primarily and the role of deduction and syllogisms in his setup of what ends up being the birth of modern logic. So let's start out with what is logic, roughly. It's the study of valid techniques of inference, or drawing conclusions from premises. And the situation typically is that we're in an argument or a discussion with somebody else and we want to establish certain results, starting with known, agreed premises, hypotheses, and then moving step by step in a logical way, in a correct way, in a valid way towards whatever conclusion that we're aiming for. Now, we know that in real life, this is actually quite hard to do. And you may have intelligent people and they can discuss quite a lot on some controversial subject. And it's very hard to get somebody to come around and change their point of view. Very, very hard. And so the ancient Greeks, along with lots of other people, were probably interested in classifying or finding methods of arguing that could be sort of put up on a pedestal as being especially valid, especially noteworthy, especially convincing. Okay, so the actual history of logic goes back earlier. There are, in fact, Indian and Chinese schools of logic, and I don't know much about that, so I'm not going to say too much. The course that we're talking about here is really towards Western thought and European thought and into the 19th and 20th centuries. And for that, it's really in ancient Greece where we find the origins of the subject. So now, amongst the many smart thinkers and philosophers in ancient Greece, there was a fellow called Zeno, who's famous for his paradoxes, lived 490 to 430 BC, and his teacher, Parmenides. So they were, I think, some forefathers to Aristotle's logic, and they set up so-called reductio ad absurdum arguments, where you adopt the opposite of what you're trying to establish and then try to reach a conclusion by finding a contradiction. So there were paradoxes somehow involved. And there was also this concept of a dialectic, which is, I think, very interesting. The idea of establishing some facts by having a kind of one-sided argument. So you have two people, and one person is kind of in charge of the argument and is trying to lead the other person, maybe an antagonist or maybe a neutral party, from a given agreed premise towards perhaps a conclusion that they may not want to accept on their own. And so this is called dialectic, and it involves the interrogator sort of asking the passive person questions, which are leading questions, which are often very narrow, so you can either answer yes or no. There's not a lot of leeway for waffling. And by this means, if the interrogator is clever enough, they can systematically lead this person into a situation that they otherwise might never have gotten to on themselves. And the idea is that perhaps this is all happening in the context of a political discussion or maybe an audience, so other people are watching this and you're trying to convince the audience as much as you are the person that you're talking to. This kind of debate has not stood the test of time, except perhaps in our legal court, right? In our legal system, this is very much what happens when a prosecutor or a defense lawyer is interrogating a witness for the benefit of the jury, trying to lead the witness towards some conclusion that they would like to establish. So this was one of the motivators for logic, is how do we set up ways of arguing that will convince other people. So now a next important figure is Plato, lived also around this time, and he was a student of Socrates and the teacher of Aristotle. So those three, succession teacher, teacher, student, three generations of thinkers probably played a greater role in the development of Western thought than any other such triple of teachers. So he was perhaps the founder of modern philosophy, a great writer. He wrote many dialogues, investigated a whole range of issues: ethics, politics, metaphysics, epistemology, which is the study of knowledge. And although he didn't actually do a lot of mathematics, he was a keen exponent of mathematics and its value. And he did ask some sort of logical questions, philosophical questions, but which are in the direction of logic. For example, questions like, what is the nature of true and false? What's the connection between the premises and conclusions of an argument? What exactly are we doing when we set up that relationship, that movement from the initial assumptions to the conclusion? And what is the nature of definition? This is a very important question. The idea that the meanings of words and establishing the meanings of words was a very important aspect of careful thinking. So that was something that was close to his heart. And he set up a school in Athens, so sort of the golden age of Athenian society, democracy. And he had a school, and Aristotle was one of many who came from all around to listen to Plato and to learn about the world. So now we come to the star of our story today. Aristotle lived from 384 to 322 BC and was one of the great influential thinkers of modern times, modern in a very broad sense. So he was, aside from being a student of Plato, he was also the tutor of Alexander the Great. That actually had quite an important effect on his life, because Alexander the Great, son of Philip of Macedonia, ended up conquering much of the known world. And so Aristotle was in a happy position until Alexander died, and then things sort of turned unfavorable for him, and he had to leave Athens and sort of go back home. But anyway, he wrote on a wide variety of things. He was probably the widest ranging writer perhaps in history. He was interested in everything, and he wrote eloquently and thoughtfully and precisely on a wide range of topics, including biology, physics, metaphysics, poetry, ethics, psychology, linguistics, economics, and for us, especially important, logic. And so before we get to his books on logic, I do want to just explore a little bit some of his thinking in the metaphysical direction. And I want to do that by actually reading from Aristotle so that we get a sense of his way of putting things, and so we get to hear from the man himself. Okay, so I have this lovely book that I've had for a long, long time. It's called On Man in the Universe. It's by Aristotle. It's one of the first books I ever owned. I joined a book club back when I was a teenager and paid a lot of money for a few books like this. And so there's various writings of Aristotle here: politics, Nicomachean ethics, parts of animals. There's something of politics and poetry and metaphysics. And I want to read a little bit, just called Book 5 from the metaphysics section. It's not that long, but I want to read it to you. So it's chapter 7 of Book 5. A thing is said to be, sometimes in an accidental sense, sometimes by its own essential nature. In the accidental sense, we say that the man of honor is musical, or the man is musical, and the musician is a man. Similarly, we say that the musician is a builder, because the builder chances to be a musician, or the musician a builder. In this sense, saying that one thing is another means that the one is an accident of the other. So in the examples we gave, for when we say that the man is musical and the musician is a man, or that the pale man is musical or the musician is pale, The last two sentences mean that both predicates are accidents of that one person. And the first sentence means that that its predicate is an accident of something that is. And the musician is a man means that being a musician is an accident of the man. So maybe that word accident that he's using there, maybe it has a slightly different meaning in the ancient Greeks than it does to us. He continues, in how many senses a thing essentially is shown by the forms of the predicate we use in speaking of it. For to be has as many senses as there are forms. Some predicates tell what the thing is, others its quality, others its quantity, others its relation to something else, others its activity or passivity, others its place, and others its time. And for each of these predicates there is a corresponding sense of being. This is actually quite important and relevant to the set theoretic discussion that we'll get to in the 20th century. Again, to be and is may mean that some statement is true, and is not, that it is not true but false. This is so in both affirmation and negation. For example, Socrates is musical means that this is true, or Socrates is not pale means that this is true. But the diagonal of a square is not commensurate with the side means that it is false to say it is. It's great that he uses that example. That example right there, crucial example from mathematics, so he's aware of that incommensurability of the side and the diagonal. Furthermore, being and is, in some cases we have mentioned, mean potential being and in others actual. For we say a thing is seeing when either it can potentially see or actually does see. Likewise, we say a man knows who either can use his knowledge or is actually using it. And a thing rests when either rest is already present in it or it is able to rest. In the same way too with substances, we say the Hermes is in the stone and the half of the line is in the hole, and we call corn what is not yet ripe. But when a thing is potential and when it is not, must be explained later. 3 dots. He ends there, that section. So there's lots of interesting ideas there. Again, for me, it's not always so clear what exactly these things mean, but we see that he is touching base with important things, and this dichotomy between potential and actual is something that figures very prominently in later discussions of set theory when we get to infinite sets. Okay, so in terms of logic, the Organon, he wrote 6 books on logic, and this was really a very mature and influential work. So he basically set up the theory of logic almost from first principles, and he brought it to a relatively mature state in such a sense that even 2,000 years later, people were still using Aristotle's logic as really the framework for subsequent developments. So very, very important work of his that we're now going to talk about. All right, so let's have a look at an example of the kind of structure that he bases his logic on. So the statement of this form: if every B is an A and every C is a B, then every C is an A. So the A, B, and C here represent some other statements, maybe predicates. And so the structure is somewhat general and doesn't really depend on the particular nature of the predicates A, B, and C. Now, this is a rather modern statement of things. Here's a symbolic statement of the same thing. Okay, so the statement, if every B is an A, can be sort of represented by this symbolic notation, capital A, capital B. The little a stands for all, or you can think of it as standing for all. And the second statement, every C is a B, is represented by this, B, little a, C. And the conclusion is that every C is an A, which is represented by capital A, little a, capital C. Now, it might seem to us that this has kind of been inverted from what it should be because we're reading it as B as an A. But actually, Aristotle wrote this in a different way, using slightly different language. And so this is really more in the direction of what Aristotle would have written, but to us it rings a little bit strange, and usually these days people rewrite this kind of thing in this fashion here. But I want to show you Aristotle's original sort of orientation to the same logical conclusion. So he would say that if A belongs to all B and B belongs to all C, then A belongs to all C. So to distinguish between these two things, let me give an explicit example. So let's go back up here to the familiar one in our situation. So if we say that if every man is mortal, and every Greek is a man, then every Greek is mortal. Okay, so in that scenario, A is standing for is mortal, B is standing for is a man, and C is standing for is Greek. Okay, so Aristotle's take on the same statement would be the following: that if mortality belongs to all men, and being a man belongs to all Greeks, then mortality belongs to all Greeks. The distinction here might be stated in somehow parallel to the distinction between sets and types that I talk a lot about. Okay? So we might be tempted to say, well, this is about sets. There's the set A, and there's the set B. Every B is an A. Every B is an A. Surely that means that B is inside of A. The set of B's is inside the set of A's. But maybe the Aristotelian point of view is more in the direction of types or properties. That here's a property, the property of being mortal, and that's a property of being a man, and one property implies another. Okay, so this is an example, a relatively simple example, of a logical conclusion which is very general, and it's almost like a law that you can depend on. It's a sort of surefire a logical argument. So Aristotle recognizes four essential logical forms for his elementary propositions, and the four is sort of 2 times 2. So there's two choices whether you're talking about all of something or some of something. All of the men have a certain property, or some man has a certain property. And the other sort of dichotomy is between whether something does have or does not have. Okay, so we get 4 different possibilities, and it's traditional to denote them by letters. The letters A, E, I, and O. And in the medieval times, this notation became quite important and formalized. Okay, so the first one, A, little a, capital B. So A and B are predicates, and this is the one we've already seen. It can be interpreted in Aristotle's fashion as saying A belongs to all B. A belongs to all B. Mortality belongs to all men. And we might say every man is mortal. Okay, so they're equivalent. They're just different ways of saying the same thing. When we write A, little e, B, it means, in Aristotle's language, A belongs to no B. For example, immortality belongs to no man. That would be a valid statement in Aristotle's setting here. Or for us, no man is immortal. No B is an A. So there's a negation here, and so going from A to E, there's a negation. And then I. Now we have some. A belongs to some B. Mortality belongs to some man. Or some man is an A. Some B is an A. That's the I. And the O is A does not belong to some B. The negation of this one. A does not belong to some B, or some B is not an A. So these are sort of 4 basic forms that are the ingredients of his arguments. So like the premises or maybe the conclusion of an argument will have this general kind of form. So now we get to syllogism, which is word meaning discourse in which certain things being stated, something else follows. And the kinds of syllogism that Aristotle is particularly interested in are these kinds here, where we have two premises, premise 1 and premise 2, and then we have a conclusion. So, for example, the one that we've already seen, okay, if well, I might state it in terms of our language. So if every B is an A and every C is a B, then this sort of implies, then there's a conclusion, an implication, a deduction. Then every C is an A. And so this is one logical rule. It's one logical rule that is valid, supposedly it's valid, for any choice of predicates A, B, and C. And we end up getting quite a few of these logical rules, and so they end up having names. I'm not sure if Aristotle gave them names, but in the medieval times they were given these Latin kind of names. And this one's called Barbara, which is a great name for a logical law. And it's called Barbara because there's 3 A's here, and so you're supposed to be able to remember that there's an A here, there's an A here, and there's an A here. Okay, so the next one is celerant, which, as the vowel suggests, has an E, an A, and an E. And sure enough, it's AEB, BAC implies AEC. So this means no B is an A, and every C is a B. And the implication is that no C is an A. That's called celerant. And then Dari is this one here, A little a B, B little IC implies A little IC. And Ferio is A little EB, B little IC implies A little OC. So for example, here's an example of Dario. All owls have big eyes. Some hunters are owls. Therefore, some hunters have big eyes. So all owls have big eyes. So owls have big eyes. Or in Aristotle's point of view, big eyes belong to owls. And this one here, some hunters are owls. This I is some. So some of these are these. Some hunters are owls. The conclusion is that some hunters have big eyes. That's Dari. And I'll leave you to come up with an example of Ferio. Okay, those first 4 were that's called first figure syllogisms, and here are second figure syllogisms. They are of the same general kind, but the common predicate here are both in the first positions. So A little eb, A little ac implies B little ec. That's called cessare, E-A-E. And then chemestris is A little ab, A little ec implies B little ec. Festino, A little eb, A little ic implies B little oc. And barocco, A little ab, O little oc implies B little oc. So let's look at Festino. So the premises here are these ones here. So the first one is AEB. That means that no B is an A. And AIC means that some C is an A. So no B is an A, some C is an A. And this one here, some C is not a B. Some C is not a B. Hope you can see that's perhaps reasonable. So here are some exercises or some examples for you to think about. These are both examples of 2 of these. The first one is all informative things are useful. Some books are not useful. So those are the premises. We're supposed to assume those are true, or we're agreeing that those are true. And now the conclusion is that if we assume those 2 are true, then it follows that some books are not informative. Okay, another one. All fish have gills. No humans have gills. Therefore, no humans are fish. Let you figure out which ones are which. Now there's actually a third figure, as you might suspect. The third figure is when the premises have their common element not both in the first spot and not mixed, but both in the second spot. Okay, and it might be a great exercise for you, if you haven't seen this kind of thing before, is to try to work out what are the valid syllogisms that have that general form. You could even give them Latin names if you like, see what you get. So this kind of syllogistic logic was worked out by Aristotle, and adjacent areas were discussed, and special cases and interpretations and meanings and so on. So it was really kind of a foundational thing for subsequent millennia. But Aristotle did not really write directly on mathematics, although he was sort of interested in some mathematical things. For example, he did discuss infinity. And he distinguished between potential and actual infinity, which is something that we're going to be thinking about in the context of sets. But he also wrote that mathematicians do not need infinity or use it. So actually Aristotle is a very early supporter of my general thesis, which is that modern set theory, which its foundations on infinite sets, is really neither necessary nor correct. So Aristotle is an ally in this general approach. I'd like to also mention that Aristotle poses an alternative view on the metaphysical level, now stepping aside from logic, going back to metaphysics, an alternative view to the view of Plato. So this is quite an important view when it comes to foundational issues for mathematics. So Plato had this idea that there are actually two worlds. There's our world, and there's an ideal world, which is somehow outside of our world. Our world may appear real to us, but it's not actually really real. So the real should perhaps have quotes here. It's the ideal world that we cannot directly see. That's the true world, and what's happening in this world is a kind of reflection or a shadow of this other world. This is a very happy thought for mathematicians, especially those who like to believe that, there's infinite sets and real numbers that go on to infinity and so on, because then they can imagine that these things are happening somewhere in Plato's ideal world. Aristotle provides a countervailing point of view. Aristotle says there's only one world. This is it right here. This is the world. This is it. This world has matter and form, so there's kind of duality in this world, but it's all in this world. And I want to point out that this Aristotelian point of view towards philosophy has been taken up in a major way by a colleague of mine, James Franklin, the University of New South Wales, who's founded the Sydney School of Philosophy, which is very much in the direction of Aristotelian thinking in this direction. He's written a nice book on this, which explains it all much better than I could. So we'll be touching base with this again, and we'll be meeting Aristotle again, so his thoughts are very important. But this is at least a first view of his thinking, and an introduction to really the birth of logic. But it turns out that there were other kinds of logic also in the ancient world, also coming from Greece, and in our next video we want to talk about those alternatives. So I hope you'll join me for that. I'm Norman Wildberger. Thanks for listening.